when you're drawing this slope field manually, or if it's being done on a computer or calculator, it's just drawing little slopes, little line segments with the slope at any given set of points that you want. I mean, we're just doing it for whole numbers here, but you could set it up however you want. It's 1 divided by the y value. So do some simple ones first, right? The y value here is, all the way along there, the y value is 1, so what's the slope going to be there? 1 over 1, right? So you have little lines that are like that. The y values everywhere there are, yeah, those are 2, so it's going to be 1 over 2. So try and connect it to that point so that it looks approximately right. But they're all going to be like that. It's easier if you look for groups on there that are all the same rather than do each individual point. I just have to do the thinking each time. Which one was the one you said was undefined? 0. So I would leave that one. Don't put anything there. You can think later what it's going to be. And then this one's going to be, what is this going to be here? 1 divided by negative 1. Negative 1, so you got this. Lines that go down like that. And then you have negative a half. And then you have negative a third. They're going to be even flatter, more horizontal. And up here they're going to be positive a third. Okay, so you get some kind of a picture like that. Again, I don't want us to get hung up on the fact that it's tedious to do. Probably you can tell that as you get closer to this, what's going to happen to the slope. Even though we didn't draw any in here, like what would the slopes be at a half? At a half, they would be 2, right? At a third, they'd be 3. They're going to get steeper as you get closer. These are going to be vertical tangents, but don't draw them on here. Okay? If you wanted to know what one of the curves is going to be, like the curve that passes through this point, 0, 1, the curve that passes through that point is something like this, just roughly drawing it. Okay? Roughly drawing it, it's something like this. It's a sideways parabola. Okay? This gives you the sense that it looks like these solutions should be sideways parabolas, right? That's what the solution is going to end up being when we're done with it here. Okay, so what do we have here? We had dy dx to solve it analytically is 1 over y. If you separate the variables here, right? Separating them means that needs to go over there. This needs to go over here, right? All the x's on one side, all the y's on the other side. So you're going to have y dy equals, well, 1 dx, I guess. If you integrate both sides here, you have 1/2 y squared equals x plus a constant somewhere on one side or the other. Doesn't matter which side you put it on. You could put it on this side because you're probably going to write this as x equals 1/2 y squared plus a constant. It doesn't matter where you put the constant. By the looks of the picture, what does it look like the constant is going to do for this? It's going to shift it left or right. Okay? It's going to shift it left or right because this is x as a function of y. This is not doing y as a function of x. This is writing x as a function of y. So if you put a constant outside of that function, it's going to be a horizontal change, not a vertical change, right? You haven't done too much writing x as a function of y, but you can. It's just saying x is, you take a y and do some kind of mathematical operations to it and you come up with the x value. That matches what you have up above. If you want to solve it subject to this initial condition, right? You know this point, sub in that point, and you figure out what the constant is, right? If you don't know an initial condition, all you can say is it's that family of curves, this. If you know the point 0, 1, you put it in, and so you put in 1/2 times that squared, plus constant. It doesn't matter where you put this plus. If some people put the plus c on this side, some people put it on the other side. When you sub in the value, you get the same thing, right? So we're subbing in 0 for x and 1 for y here. So we get a half, right? Constant is what, negative a half? Is that right? So then your function is a half y squared minus a half equals x. That matches what we have up there. If you were to graph it, okay, it matches that. Let me check if I can put that into GeoGebra if it'll graph that. Yeah, this is that family of curves, right? The specific one that it is this one here, where the constant is a half, right? Or I'm close, anyways. Okay, that's the specific one. That's the solution, right? Again, all you're doing when you're subbing in the point is you're saying it's one of these, and I want the one that goes through this point here, right? You put a point exactly there or something, and then you're trying to match this up, right? That's all you're doing algebraically when you put that in there, so it passes through that point. Okay? Are we okay with this idea here? Example 1 and 2. This is Where did I put that?
It should say example 1.
Oh, because I took out some examples. I know what you're saying. Yeah, 1 and example 1. Don't freak out. No one's freaking out.
I was freaking out. I got scared.
I don't know what I mean. Slope field here is that there's number one. I guess there's some vertical tangents. It looks like there's sideways parabolas, and we've already mentioned a lot of the things I was getting at. Why I put that question in there. If you draw this, you can use the slope field to support it. There are some other ones here I want you to solve. I want you to draw the slope fields and make a prediction about what the curves are going to look like, what shapes they are. Unfortunately, you haven't done conics in grade 12. We've talked about some of them here in this course, but solve that. Come up with what the slope field looks like, and then solve it. And this one, I want you to look at this, and I want you to notice all the questions up here. I said, draw the solution. So I said, solve this differential equation algebraically. I want you to notice the next one. It says, can you find an algebraic solution to this differential equation? So, using your powers of logic, why would I ask that question if the answer is yes? Exactly, right? Because I would have told you to solve it. So you think about that and why you can't, okay? I'm telling you that so that you don't sit there and try to do it, think you're doing something right when you're not. All the kinds that we're doing algebraically are ones that are separable, where you can separate the variables onto each side. Oh, sorry, okay. Can you get going on finishing this section? Please notice that there are a lot of pages, but that's only because each question takes up a whole page. This is very poor graphics from a calculator program. Okay?
Is this application going to be on the same test as the...
No.
What is that? So in my own time when I'm studying, I should just be studying?
Let me finish this and then you can ask those questions. The rest of this you can do. We have 10 minutes or so right now. You can work on this. Next time we're probably going to move ahead with stuff with the goal of getting it done earlier. We're putting off the tests quite a while. The idea is that we have lots of class time we're going to use to make sure you understand everything before we do the tests. Okay? But I want to make sure that we're done well ahead of time for people to start working on AP prep if they're doing that. All right? Can you get going on finishing